Hi, good afternoon, everyone. My name is Rahul Kulkarni. I welcome you all to this webinar. Is your data holding your industry 4.0 success? So we'll give a couple of minutes to people who are yet to join. So they are trying to join in. So we'll just wait for a minute and then we'll start with the webinar. Yes, so the people are joining in. So we'll be starting now. So good afternoon, everyone. My name is Rahul Kulkarni. I welcome you all to this webinar. First, the webinar introduction. So this webinar is jointly hosted by ATS India, Sarla Advantech Pvt and HighByte. My name is Rahul Kulkarni. I lead the pre-sales and product team at Sarla. Along with me, I have John Harrington. He's a co-founder and chief business officer for HighByte. Hi, good morning, John.
Good morning, Rahul. Or good afternoon.
Yeah, good afternoon. Thank you. Thank you for joining. First this webinar, the agenda for the webinar, that I will be introducing some of the Sarla offerings, then about partnership with HighByte and some other contents. Then I will be handing over to John, so he will take us through these new all the concepts like Industrial DataOps, Unified Namespace. Then he has certain use cases to share with us, so he'll be doing it. And later on, we'll have a question and answer session. So for all the attendees, so the tool via which you are joined, the GoToWebinar tool, so you can post in all your questions anytime during the webinar. We will answer those questions at the end of the webinar. We have dedicated time for it. So you can post in your questions, so we'll answer all of them. Yeah. To begin with, first the introduction to Sarla Advantech Pvt. We are in the manufacturing IT solution services from last 20 years. We do different type of automation solutions, like automation softwares, the manufacturing integration, MES, MOM softwares, industrial data analytics, and many other solutions we provide to the manufacturing industries. We are not restricted with any single type of industry. We work across multiple industries like pharmaceutical, automotive, energy, metal, aerospace, and all. We have long-term associations with some of the principal companies like GE Digital, Kepware, and from 2017 onwards, we are a part of ATS Global Group. So Sarla Advantech Pvt is also called as ATS India. So that's how that's what we represent here. We are ISO 9001:2015 certified company, along with ISO 27001 certification. We are overall more than 400 people. Working in 15 different offices across the globe. We have 150 plus major customers in manufacturing sector. 75% of our business comes from repeat business from our customers, and we have more than 2,500 projects delivered. So all these automation and type of projects across our customers, we learn a lot about the things, how they are operating, and now how the industry 4.0 is changing the complete architecture or how they are adopting to it. So while discussing with many of our customers, so there are a lot of challenges related with the data they face, and this comes especially when they try to build up a new type of solutions, like people are building industrial IoT solutions for their remote monitoring systems, multi-plant visualization kind of solutions. They do the data lake applications. There are analytics applications going need to be done. So for all these type of applications, the first question comes in, where is my data and how I can utilize the data properly. So if we can segregate this data, so there is a variety of data, there is a velocity to this data and a volume of data. So the data generated on the manufacturing shop floors is surely much different than any other industries. So if we say the variety of data which is there, so we have a lot of different systems on the manufacturing shop floor, like these are the systems supplied by many different vendors. These are commissioned at very different point of time. They were not meant to communicate with the outside world. And now Industry 4.0 coming in picture, we need to integrate those systems for the applications like what I just mentioned. So, that is one of the challenge, that we have variety of data. Then the velocity of data. So typical the data source or the type of data, apart from the relational databases, the SAP MES systems are there. Apart from that, we have a challenge with the time series data, which is continuously getting generated by the PLCs and the SCADA systems on the shop floor. And the volume of data, as I said, this data is getting continuously generated. So we need some solution to aggregate all this data together and utilize it thoroughly. So while discussing with our customers, so we realize that this is a challenge and we need some solution to it. So that's where the industrial DataOps concept comes in a picture. We basically try to answer three major challenges. So first is identification of useful and raw data. How can we do that? So we need some tool where we'll be in a position to identify what is my useful data, what's my raw data. We should be in a position to segregate that data, filter it out, and do the operations over that data. Second challenge comes how easy it is to connect to the multiple sources of data, because the manufacturing environment systems are already commissioned. They are doing their own work, like control systems, SCADA, PLCs, they are there. And these systems, we need to now connect to the system. So we need some tool which will be able to easily communicate with these systems and pull out the data, and also to share the data with the other consumer systems. And third system, as most of the OT systems are there, that we need some platform which is like a no-code or low-code platform. So where there not be much scripting or programming needs to be is required. So this is a point we came across HighByte as a solution. From Sarla, we did a partnership with them, HighByte, early this year. We are working with them on many different solutions, and we're seeing a lot of traction here in India. So a lot of companies are exploring it. Some of our customers are already doing the POC with us to explore the solutions. So what are there? And it has good future that to manage all this data. So we need a solution like HighByte, what it has. So with that note, I would like John to take us through the more details about the industrial DataOps, unified namespace, and some use cases and all. So handing over to John.
Thank you, Raul.
Yes, John.
And are you, here we go. Okay. Thank you. If you can tell me when you can see my screen now.
Yes, we can see it, John.
Excellent. Well, thank you everyone for joining our webinar. This is exciting for me, and I'm very happy to be here and thrilled that the Sarla team and Raul have invited us to come. Today, as we walk through this webinar, I'm going to start out, give you a little bit of background on myself and on HighByte, talk about those Industry 4.0 data challenges that Raul was just talking about, and then talk about the emergence of this new practice called Industrial DataOps, what it is, how you mature through it, where there's what some of the solutions are, what is a unified namespace in the use cases. We're going to have another follow-on webinar in January, focus more on HighByte software, where we get into demonstrations. But today is really going to focus on these concepts as an educational webinar. So to get started, it's great to meet you all. It's great to be in front of you. I'm John Harrington, as Raul said. I'm the co-founder and chief business officer at HighByte. A little bit about my background. I've been in this industry my entire career, providing software solutions for manufacturing, as well as working in manufacturing facilities, bringing in technology and software in order to drive productivity. For the 10 years prior to forming HighByte, I worked for Kepler Technologies, so very much in this industry, the data industry, in industrial automation and in manufacturing. I led the product management team there and then went on to lead the business strategy for the IoT business unit at PTC. I formed HighByte back in 2018 with my two other co-founders. All three of us had worked at Kepware together. In fact, our CEO of HighByte was the former CEO of Kepware, and for 10 years, and prior to that, he was the lead software architect. So we have a lot of experience in this industry, and we've had a very broad view, both at the data side and the industrial automation side, as well as at the IoT side, as we worked in with PTC, one of the leading IoT vendors. So we formed HighByte because we recognized there were still a number of challenges with data, and how do we get data into the applications in the people's hands so that they can deliver on their digital transformation or Industry 4.0 goals. HighByte is based in the USA, in Portland, Maine. It's about 2 hours north of Boston. So to date, we have over 30 customers in a wide range of industries within manufacturing. So very focused on manufacturing. We have customers in food and beverage, and pharmaceuticals, pulp and paper, industrial products, consumer products, energy and mining, so a wide range. And that number is growing. We're working with another 60 to 80 additional customers or prospects who are currently evaluating the HighByte Intelligence Hub. We have a global customer base as well as a global partner network, of which Sarla is our lead partner in India. So it's very exciting for us to be here today. I want to start out by talking about what are these data challenges with Industry 4.0, and to get there, let's talk about what Industry 3.0 started with. So Industry 3.0 is really about how do we automate our manufacturing processes. And the technology was all about how do we pull data out of the factory floor through the I/O to the controllers to the connectivity to SCADA and MES to automate that process. And many companies are still working on their Industry 3.0 goals. But what we see with Industry 4.0 is an evolution into taking that data that for many years has been available in the OT domain to execute on the automated processes and pull it into the business domain so that companies can start leveraging this data throughout their entire enterprise and their extended enterprise through their supply chain. So how do we get data into the hands of people like the R&D team, the quality team, the maintenance team, the supply scalable way in a high resolution maintainable way such that they can execute on the business processes that they have to execute on. In doing that, they found that they also have to collect more data. So we're seeing the advent of edge gateways and smart sensors on the factory floor to collect more data. And then all of those users that I had talked about, those business users, they all have their own systems. So it's not just about getting data into the SCADA and MES to execute the process. Now it's about getting data into other systems like a CMMS system or a quality management system or an ERP system. And then we're seeing the advent of data lakes and analytics in the IoT platforms. In many cases, these are in the cloud, but they don't have to be in the cloud. In some cases, people are keeping these on premise if they don't have the cloud infrastructure to be able to leverage them, but they're still implementing these practices. All of these projects and practices are great, and they're adding business value to customers. However, the challenge is how do we link them all up? And as you can see from my diagram on the right here, making discrete point-to-point connections sounds like a great idea when you get started, but as that starts to scale out, you end up with a lot of connections and a lot of maintenance. And the first challenge is connecting. The second challenge is over time, being able to respond to changes in maintaining these connections, which of course the factory is always changing in all of these needs. In fact, analytics and dashboarding and whatnot has driven much more evolution in an iterative process rather than define it once up front and set it and leave it alone for 20 years. Now we're constantly changing and evolving what data we need. So we need a much more dynamic approach than creating these custom programmed point-to-point connections. Even though we have APIs, it still gets overwhelming to try to connect all these systems. In fact, beyond the data connection, we also have a challenge with making sure that the data is usable. So one of the challenges with industrial data is that we're using the data now. It was put in place for process control, but now we're using it for different use cases. So machine predictive analytics or predictive maintenance. We're using it for product traceability. We're using it for quality analytics. A lot of Also, when you go and look at the data coming out of your factory, many people find there's been a lack of standards applied to the machinery. In many cases, the machinery was purchased over time. It came from various vendors, and it was implemented by various system integrators. And as a result, the data structures on each machine tend to be different. There weren't any standards put in place, because at the time we didn't have any use for standards. There wasn't any need to implement that. Well, now the challenge is, how do we standardize that data so that we can roll out things like analytics and dashboards at scale? So we can roll them out across our entire factory, and we can roll them out across our entire enterprise, across multiple factories, and be able to look at the data in a consistent way. Not only do we need to do that, but we need to add context to that data. Data in the industrial world has been very raw. We get numbers that come across. We get values that come across with a number, but we don't necessarily know, well, that's the pressure on the pump, that's the filling tank, that's filling the tank of stage number 3 in our brewery process in this site. That's what we mean by contextualizing data, adding descriptive information that makes it so that someone outside of the OT domain can use this data. And that's critical as we merge the data together across multiple sites and across multiple lines, and as we provide it to people outside the OT domain. Now, the way to solve this data connectivity challenge and the data usability challenge, we've seen a new practice come into play called Industrial DataOps. And Industrial DataOps really came out of the IT world, where they talked about data ops, companies like Hitachi and IBM. And they defined data ops as the preparation and delivery of data for analytics and dashboarding and visualization purposes. So how do we prepare that data? Well, in the industrial space, we never used to need to prepare it. It would only go to one source, but now that it's going to multiple, we need to be able to prepare and deliver data more efficiently. And so the idea with industrial data ops is we take those practices that were developed on the IT side and we adopt them and adapt them into the industrial side of the world. So this isn't necessarily a technology, it's a set of practices and responsibilities. It's a set of processes, like defining data contracts between systems, defining data governance and who has the ability to make changes, defining semantic data definitions as to how are we going to talk about our pumps, how are we going to talk about our valves or our sheet metal presses, and do that consistently across the enterprise. In defining a consistent and logical information and system architecture. It also requires changes to the team. In the past, many OT teams were really focused on process engineers, controls engineers, quality engineers, electrical and mechanical engineers. Now what we're seeing on the OT side are people like information architects or integration engineers and data engineers and systems architects. And we see that architect in that data engineering role coming into the OT team. Now, those sort of roles have been on the IT side for many years. And in some companies, they're still on the IT team, but they're being assigned to the OT team to work on getting access to that data. In other companies, what we're seeing is the OT team is starting to hire those engineers or those roles to join them and to become part of their team. And the third component of industrial data ops is technology. Now, technology includes a number of different concepts. Industrial data starts at the edge. Industrial data starts with the machinery. So we need to think about the edge and think about what do we want to do close to the machine? What do we want to do in our central servers and data infrastructure that we've had in place for many years? And what do we want to do in the cloud? So we may want to adopt edge computing. We need to move data seamlessly through those three levels. The edge, sometimes referred to the fog, and then the cloud, the data centers, and all of our different use cases. We need to think about unifying the namespace, modeling the data, and leveraging open standards. And it's all of these put together, the processes, the people, and the technology that really make up industrial data ops. And really, it's a discipline that companies need to start working with. Now, industrial data ops can't be just rolled out enterprise-wide instantaneously. There's a maturity. Companies need to start at one spot and they need to mature through it. And it takes time and it takes practice, but you get great value when you get to the end. And that's really where the focus is. Now, you don't need to roll it out across the entire enterprise consistently. You could roll out some plants or even some sections of the plant at one level and others at another maturity level. But the key is that you understand the different maturity levels and you walk your groups through them. So we've identified 4 levels of maturity when it comes to industrial data ops. The first is data access. And that's really where we use open protocols, we pull discrete tag values, we push them up into our data lakes, whether that's in the cloud or whether that's on premise. And we make that data accessible to our analytics. Now, this is the first step, and this is a great step to get started. The next step is data context. So it's taking those data points and those over the open protocols, and it's adding descriptive information to it. It's normalizing the values and making sure that they conform to our needs and our approaches, to our standards. It's defining some simple structures and presenting that to the IT team for their consumption. The next step is site-wide industrial data ops. And when you do it site-wide, you need to define standard models, creating real structures, multiple data values put together for specific use cases. It's being able to filter the data, not just provide it at a consistent rate, but filtering it for the different use cases, and maybe even making it event-based. Providing a site-wide view and standardizing your namespace across that. And then the final stage is enterprise. In enterprise, when you roll it out across multiple sites, really focuses on data governance and on how do we synchronize our data across these sites so that when we integrate it together, it seamlessly allows us to have visibility across the sites without replacing our existing equipment. So we need to work in a brownfield environment where we've got existing sites with existing technology, but we want to standardize and abstract the data away in such a way that we can make that data usable. What's important is that you recognize as you move through the maturity model, the benefits increase, and that's what makes it all worthwhile. The point is that with data access, this data is very much usable by the OT team to perform things like analytics. As you move on to data context, or the data access really provides controls. Data context adds for analytics. As you move into site, now you can really leverage it throughout the business because we've added the context and we've assembled the data. And then enterprise, we're able to leverage it across multiple sites. We're able to onboard brownfield locations without having to swap out equipment, without having to standardize our underlying systems, because we're able to inject this data in a standardized and consistent way and provide true multi-site visibility and comparisons. To give you a view of what this looks like, I put together some simple data and showed you what the data looks like as it goes through the stages. So stage one, we're getting OPC access to data. We still have our data structures, from a Modbus PLC. So we've got some values, 365 and 35. And we've got a temperature, 85.34. As we move into data context, we're adding things like unit of measure. And what is this data? You move into site, and all of a sudden we've taken these 4 different values. And by the way, in the data access, these are 4 values that may be within a set of 10,000 or 100,000 total data tags available in your factory, maybe even 1 million data tags available in your factory. So they're not organized in any way. These are just plucked out and available for someone who knows what to look for. Now, as we move into site, we're now standardizing them in specific structures. And they're structures that people outside of the OT domain would be able to pick up and use and understand. We've aggregated the pressure values with the power consumption, with the temperature, so that we can perform analytics on this pump in our brewery. And then as we move into enterprise, you don't see a lot of change in the actual data. We've added site to the data. But where you see a lot of change is that these same structures are rolled out across the enterprise. And now you've got a governance layer, and now you've got the ability to pull and aggregate data across multiple sites. And this is where the true value comes in implementing Industrial DataOps and in implementing Industry 4.0. So how do we do that? Well, today, I'm not going to give a full pitch on HighByte, but I did want to introduce the HighByte Intelligence Hub. The HighByte Intelligence Hub is one solution that you can use to deliver Industrial DataOps, the technology for Industrial DataOps. So the HighByte Intelligence Hub, you'll notice, number one, takes a very different approach to integrating data in the industrial world. Traditionally, we've all used the Purdue model, or sometimes referred to as the ISA 95 stack, where you move data from the IO to the controller, to the SCADA, to the MES, to the ERP. And it's a very linear model, and data moves from one step to another. What we see with Industry 4.0 in digital transformation projects is that that needs to change. Data exists in different systems when those systems can use it. But in many cases, data from one system isn't needed in the next system up, but it is needed in other systems. So how do we short circuit that layered approach? Because if we stick with our layered approach, we're going to overload our SCADA systems and our MES systems with data that may be only needed for level 4 type of analysis, or is only needed in the cloud for analytics of R&D, which was never really anticipated in the Purdue model. So how do we pull data out and combine data across the layers? And that's where HighByte took a hub and spoke approach to data integration. So we've developed the HighByte Intelligence Hub, which connects to multiple systems. It can connect to your sensors via protocols like MQTT, or being able to consume CSV files even. It can connect to your PLCs via OPC UA. We can connect to your SCADA and MES systems via SQL or REST. And we can connect to your ERP and other databases out there, again, with SQL and REST. In fact, today we're actually releasing an OSI Pi connector, which will connect directly into OSI Pi to get access to that historical data that many companies have in their historian. So the key is getting access to data in all your different industrial and IT systems and aggregating that industrial data together. Once you get it together, you need to work with that data. You need to standardize it and contextualize it. And we do that through our modeling engine. Now, the modeling engine allows you to create models, standard models. In a factory, you typically would have 3 major types of models. You may have an asset model if you're doing predictive asset maintenance. You may have a product model if you're doing quality or R&D and analytics or product traceability. And you may have a process model if you're trying to analyze your throughput or your yield or your OEE. So you create those standard models and you roll them out across your site and across your enterprise, and you leverage those models to standardize, normalize, and contextualize the data. Now, all of this needs to happen by humans, by people that define how the data flows into these models. And the people that really understand that source data is the OT team. So the Intelligence Hub was designed for the OT team to be able to add this context and add this modeling to the data. The Intelligence Hub is an application. It's a lightweight application. It's browser-based, and it's completely codeless. So you're able to go in, create connections to all these different systems, aggregate the data in, model it, and then send it out through an application. Now, I've talked about Unified Namespace in a couple of points in our presentation, so I wanted to define what it is, because this is another new term that we're seeing in our industry. So the Unified Namespace, by definition, we say it's a consolidated, abstracted structure by which the business and industrial applications can exchange industrial data. So that's a mouthful and that's a lot of words. What does that really mean? When we talk about consolidated abstracted structure, we want to use a system to do that. In fact, in many cases, people are using an MQTT as the data protocol and an MQTT broker as that structure. The reason that they're doing that is that it turns out that an MQTT broker is an extremely scalable system to exchange data. It was designed for this, and people are using this throughout industry and in the IT world to move massive volumes of data around. It's an open protocol, so it's open for anyone to use, but yet it's still very secure. leveraged the ISA 95 hierarchy of company, site, area, line, work cell. We generally then add in asset and sensor, and we use that hierarchy as a way of organizing data within your company so that others outside of the OT domain can logically go and access data, because they often think of these structures when they think of data. The other key piece is, of course, we need to exchange data. So what does that data mean? Well, with MQTT, you get a publish and subscribe type of approach to exchanging data. So one system publishes it in, another system can subscribe to that topic structure and then get access to that data whenever it changes. Now, when we talk about that topic structure, there are different data sets at different levels. So when you think about like the site or the area level, you may define a profit and loss. Of course, you don't define that at the cell or the asset level. It would sit at that higher level. You may also have a schedule at the site or area level. When you think about a line, you may have things like OEE calculations or lot data or batch records. When we get into work cells, we may have things like compliance and quality or traceability. And then when we get into assets, we get into predictive asset maintenance or power consumption. So it's interesting to think about the user of the data. At what level are they thinking, and at what level of abstraction do they need this data prepared? So in general, when we think about a unified namespace, we have this MQTT broker. It's got its topic namespace, the payloads of data, it's pub sub, it's secure, and it's enterprise capable. And we've got all these different systems that can publish and subscribe to the data. Well, the challenge is that in the industrial world, many of our systems don't support MQTT yet. Also, when those systems are publishing in many cases, if they do support it, they have a lot of constraints on how that data is structured. Not only that, but the payloads at many of those topic levels are really combining data from multiple different systems. It turns out that the raw data in many cases comes from the operational data from, say, the OPC servers or the process data. But in many cases, the context comes out of other systems like your CMMS or your MES system. So we need to combine the data payload before we place it into the broker. And if we have every piece of machinery publishing the data, we haven't yet standardized that data. Furthermore, when we think about the target systems, many of those also don't support MQTT. So we have this challenge of MQTT is a great structure for our unified namespace, but we need something on either side of it to make it much more usable. And this is where intelligent gateways like the HighByte Intelligence Hub can come in. It can provide access to the various IT and OT protocols. So we can read data from a SQL database, pull data from a REST server, we can pull that OPC data or that data from the sensors, and then we can aggregate it, standardize it, model it, publish it into the namespace in that standard way. Essentially, we provide that namespace governance. On the right side, we also provide the ability to subscribe, transform, and deliver the data to the systems that don't support MQTT, and the systems that do can just reach out and directly grab it and subscribe to it. So all of those challenges of utilizing the namespace are now overcome by surrounding the namespace with a gateway like the HighByte Intelligence Hub, making the unified namespace a great solution for moving data throughout your enterprise. Now, what I just talked about is the most common approach to a unified namespace, where we're moving the data through an MQTT broker. This makes the data very accessible, and many people talk about democratizing the data. Now anyone can get access to that data. But in many cases, companies don't necessarily need to do that. We also hear about people talking about unified namespace, but wanting to move the data into their data lake. In which case, HighByte can still be that data governance layer in the gateway into the data lake, so that when it's in the data lake, you now have a highly structured unified namespace of data, and you don't have what sometimes is referred to as a data swamp, because everyone has put data in and no one knows how to find the data that they need. Thirdly, we've seen people talk about using the unified namespace right within a solution like HighByte, where they're just trying to integrate systems, but they need to unify the namespace of the data as they move it through. So HighByte can be used in all these different cases, and in many cases, people are doing a combination of these three. They maybe start out by publishing data by doing the integration piece, and then they start publishing data up to the cloud, and over time they want to implement a local broker so that they can get access to it. Or in some cases, they're going to start with the local broker and then publish that into the cloud as they start to adopt cloud type of use cases. Now I want to talk about some key use cases that we've seen implementing industrial DataOps. So the first one is what I've been talking about. How do we integrate data from multiple systems, pulling process data, historian data, MES, or other data sources together, merging that data, standardize it, contextualize it, and publishing it out. You can publish to a UNS, you can publish directly to the cloud, or you can publish directly into your target systems. But the key is you standardize that data and publish it out in a uniform way. Another key use case that we've seen is utilizing high-resolution data analytics. Many people are trying to perform predictive analytics on machinery to identify problems before they occur. And HighByte has been used for this to be able to collect data. When it comes to very high resolution data, we're talking millisecond data or 5 millisecond, 10 millisecond data, sometimes even faster than that. We're talking things like vibration data, power quality data, things like that. It's critical that the source system can buffer that data so that when we pull it out, we're pulling out sets of data. But it's critical when you pull out that set of data that you're able to standardize it and contextualize it before you send it on to the analytic. So HighByte's developed some technology to be able to pull that set of data. It could be 1,000 records, pull it in, process it through, and then publish it to the cloud or publish it to an analytic. We've also been rolled out across multiple sites. So it's critical when you're doing that enterprise-wide deployment that you have data governance and that you've standardized your models at each site such that when you aggregate the data into a common data lake, it's consistent and it's unified. In which case, you need to provide a solution to each site's OT team that leverages those common models but allows them to do the data mapping to their source systems. And then as things change over time, you need to be able to update those models and have that local team update their source systems data mapping. So the ability to provide that distributed environment where you've got multiple deployments running is critical in order to implement multi-site or enterprise-wide deployments. And finally, it's important to recognize that this isn't just for the analytic purpose or the dashboard purposes. Sometimes we need to push data back into our process control environment. And these data hubs or the intelligence hub can be used to pull the data back down to set points or to drive set points that are analyzed and pushed back into the equipment. Obviously, it's very important that we're secure in our data sets and that we're making sure that we have consistency in our data pipelines. But a lot of people are starting to look for how do we leverage this analytics to drive change on the factory floor. And HighByte can be used to move that data down. So in conclusion, the center of your Industry 4.0 strategy has to be data. Data it's the water, it's the fuel to drive the strategy. However, it must be prepared for the target system for specific use cases. It must be curated by the team that understands it, which in our industrial world is the OT team. And the practices that we use and the solutions that we use must be focused on scalability and maintainability. Industrial DataOps provides the discipline to encompass those practices, the team, and the solutions to deliver these goals. And we're happy at HighByte to be working with the Sarla team to provide the experience and the solutions to deliver on these projects. With that, I'd love to turn it back over to Raul and open it up. I don't know if you had any conclusion slides, and open it up to questions.
Yes, thanks a lot, John, for this detailed presentation about Industrial DataOps and the Unified Namespace. Yes, we have like a lot of questions coming in, so I will go through some of them which are like general and useful for all the customers. So one of the question coming up, like when and what level of automation edge device or computing shall be used? Like whether we can implement like do we need any additional edge computing along with HighByte, or HighByte can act as a edge computing itself?
So it depends what you want to be computing at the edge and what your source data is. HighByte can run on very lightweight IoT gateway type of compute devices. We've tested it and run it on Raspberry Pis, for instance, which you know, we don't expect to be in a lot of industrial environments, but that architecture, that single board compute device, small form factor compute device, we are seeing as a typical IoT gateway across industrial IoT gateway, and is being used and delivered by many vendors. So it can run on very lightweight hardware, depending on the amount of data that you're publishing through it. But we'd be happy to get you more information on that. But yeah, we can run on that IoT gateway, and depending on the amount of compute you need to do, would dictate the size and scale of the edge hardware.
Yes, yeah, good. The other question which is in there is from the architecture point of view. Where does the HighByte as a software resides? Whether it's on-premise, or can we distribute it across the plant, or can we have multiple instances of it? So how the architecture would look like?
Yeah, that's a great question, and a lot depends on what you're trying to implement and to what level you're going, and as well as what is the architecture and infrastructure that you already have in place. Some people are implementing a single hub, and they're implementing it to consume the industrial data and, for instance, publish into a data lake. Other people we're seeing have various security and networks in place where they may have an OT network and they have an IT network, and in order to move data across them, they have a DMZ, and we're seeing one intelligence hub implemented on the OT side, maybe a MQTT broker in the DMZ, another hub on the IT side consuming data through the broker, mixing it with additional IT level data, and then publishing potentially up to the cloud or into a data lake or an analytic. In other cases, we're seeing people implement the intelligence hub for different use cases within a single site. So you may have multiple hubs within a site. We've architected the software such that it's very easy to deploy. In fact, you can containerize it and deploy it as a container. It's also easy to manage and maintain. You can define a single host hub as a host to a portal that can then reach out and configure multiple hubs either within a single site or across multiple sites. When you're configuring those hubs, you can also compare and push structures from one hub to another. So we've tried to make it very easy to have a distributed environment if that's the goals and that's the approach that you're trying to take, or to have a centralized architecture if that's the way that what your needs are. So it would really take digging in on what the needs are, what the goals are of the projects in order to define that. But both of those, distributed or centralized, are able to be implemented with HighByte, and we have customers implementing both.
Yes. Yeah. Thanks, John. So the other question is related with the product itself, the HighByte. So maybe I can also take it up. So HighByte is a software itself. So as John explained, so it can be installed on the any hardware. It can be containerized, or you can use on the edge devices also. So it's a software component. Other question is coming up. Yes, can we share some reference architectures? Yes. So after this webinar, we'll be contacting you. We'll be sharing some of the detailed architectures, how you can utilize it. So of course, those will be shared from our side. Then there is one more additional question coming up, like as like most of the data is going to the cloud systems, are there any native cloud connectivities possible from the HighByte as a tool?
Yes, so HighByte has native cloud connectivity to Azure, AWS, and to Google Cloud Platform. So with Azure, we can publish up into the IoT Hub or Event Hubs. With AWS, we can publish into their Greengrass, their Edge Greengrass solution, or into their cloud-based IoT Core. And with both of those, we would just publish over MQTT. However, we can also publish into IoT Sitewise and into a Kinesis data stream using specific connectors that we've implemented their APIs or their SDKs for. And then with Google, we can also publish into their IoT Core, I believe they call it, to publish IoT data into the Google Cloud Platform. So all three of the major cloud vendors were able to publish data into through their native services.
Yeah, good. And I think one more question I can take up, like how security is handled from source to destination when the data is getting passed through HighByte?
Yeah, it's a great question because security is critical. And one of the reasons that we implement various SDKs for these different applications is such that we can improve the security with that application. But we support secure connections across all of our protocols, and each one has its own security approach. So with OPC UA, you can authenticate, you can encrypt your data using the OPC UA authentication and encryption security that's built in. With MQTT, we also support security and encryption there. And through SSL, we support HTTPS for the HTTP REST connections. So with each connection, we have a secure approach to moving data. And of course, the source or the target system also needs to implement security. I would say probably the only area that we don't have security built in so much is when you're reading and writing to CSV files, which obviously there is none there. It would just be your local file system. But the key is that for each protocol that we support the level of security that they provide. And then we provide a layer of security on top of that. The HighByte system, you can define usernames and passwords, and you can define roles. You also can integrate it with your user authentication systems that you use. We now support SAML, which is an open standard for integrating with user identity systems that you use within your company. So the HighByte system is secure, as well as the ingested data and the published out data.
Yes, yeah, good, John, thank you. So there are a couple of questions like which are related with the licensing and the product and the POC related things. So of course, as the Sarla in India, so we'll be helping you out with all the POC related things. Will be there are the like a demo versions are also possible, so we can help you out with it. So we'll reach out to you separately to explain you how the licensing things are there. And there are some other question coming up. Those are related, like very specific to the product itself. So just as an information, like as John during the start he said, so we have a follow-up webinar. We're calling it in the 3rd week of January, where we'll be more concentrating on the HighByte as a software itself. So where we'll be more in detail. We'll be discussing about what are the performance related, how much minimum frequency you can go, what type of data we can collect, and all the product specific related things we'll be discussing that. And additionally, we'll be also sending you the relevant documents, and we'll also be sharing the recording of the session, so which you can refer anytime. So I think others were the general questions, so which I clubbed it together. So I think there are no more additional questions there. So I think, yeah, thanks a lot everyone for joining our session. So we'll get in touch with you again. Thanks a lot, John, for joining us and representing HighByte here for our Indian customers. So thanks a lot for it.
Thank you, Raul, and thank you to the team for hosting and for inviting us to come and speak. You know, we look forward to the session in January, and we look forward to working with more and more customers in India and in the region. So,
yes.
Thank you.
Thanks a lot. Thank you, everyone. Thank you.